Happy morning, friends. Here's yours, Dr. Ajanta. Welcome to day 11 session. Today we are just going to discuss about namespace, mapping from name to objects, and scope of a variable. What is name in Python? So if you have ever heard the gen of Python, that is the type, import this in the Python interpreter, the last line states namespace or one honking great idea. Let's do more of those. So what are these mysterious namespace? Let us first look at what name is. Actually, name, also called identifier, is simply a name given to objects. Everything in Python is an object. Name is a way to access the underlying objects. For example, when we do the assignment, A is equal to 2. So 2 is an object stored in memory and A is the name we associate it with. We can get the address in RAM for some objects other than built-in functions like ID of. So let's look at how to use it. So with an example, see here dear friends, A is equal to 10. Sorry, A is equal to 9 here, and when I just want to print ID of 9. So here one more example, that we are just referring one thing by the value and another is through the variable it just assigned. And see here, both refer to the same object 9, so they have same ID. Let me just see here dear friends, where it is stored and what is the exact reference of it. Okay, let's make things a little more interesting. See here dear friends, in the next example, you may get some different values for the IDs. That is, see A is equal to 2, okay, print ID of A, that is the variable where it is stored. And next one, A is equal to A plus 1. And that is also, it is A, but it is referenced to the next variable which is incremented. And the next one, ID of 3. ID of 3 is in the sense, here we have assigned a value to the variable A as 2 and next we have incremented with 1 and though we just say it as a 3. And now let me just have the other variable B is equal to 2 and see here dear friends, we are just going to have the same here where B and 2 are both. Okay, both are equal. And see here, when you just come for A is equal to 2, the ID is different from A plus 1 and the 3, where A plus 1 and the 3 are same. And to the same when coming to B is equal to 2, where it is stored, B, and what is the value of it? So that is also 2. And what is happening in the above sequence of the steps? So let us just have a diagram here, which we just say memory diagram of variable in Python. See, initially an object 2 is created and the name A is associated with it. When we do A is equal to A plus 1, a new object 3 is created and now A is associated with this object. Note that ID of A and ID of 3, okay, have the same values. Furthermore, when B is equal to 2 is executed, the new name B gets associated with the previous object 2. So this is efficient and Python does not have to create a new duplicate object. So this dynamic nature of name binding makes Python powerful. A name could refer to any type of objects. For example, we can just say a is equal to 5 or a is equal to hello world or a is equal to a sequence list as 1, 2, 3. All these are valid, and a will refer to 3 different types of objects in different instances, and functions which are objects too, so a name can refer to them as well. And see here, dear friends, we are having a function here which is going to print hello. Okay, that is the name of the function is print hello. And what is the exact concept here is we want to print a word hello. And when on calling, that is calling the function print hello, and we would be executed with the one hello onto the top screen. So the same name a can refer to a function, and we can call the function using the same name. Here, what is a namespace in Python? See, now that we understand what names are, we can move on to the concept of namespace. To simply put it, a namespace is a collection of names. In Python, you can imagine a namespace as a mapping of every name you have defined to corresponding objects. So different names can coexist at a given time but are completely isolated. A namespace containing all the built-in names is created when we start the Python interpreter and exists as long as the interpreter runs. So this is the reason that built-in functions like which we just say id of or print etc. are always available to us from any part of the program. And so each module creates its own global namespace. These different namespaces are isolated, hence the same name that may exist in different modules do not collide. So modules can have various functions and classes. A local namespace is created when a function is called, which has all the names defined in it. Similar is the case with class. And see here, dear friends, here it is the diagram which may help to clarify this exact concept as built-in namespace, global namespace, and the local namespace. Next, let me just jump on to Python variable scope. Although there are various unique namespaces defined, we may not be able to access all of them from every part of the program. So the concept of scope comes into play. A scope is the portion of a program from where a namespace can be accessed directly without any prefix. At any given moment, there are at least 3 nested scopes. That is the scope of the current function, which has local names, a scope of the module, which has global names, and outermost scope, which has built-in names. So when a reference is made inside a function, the name is searched in the local namespace, then in the global namespace, and finally in the built-in namespace. So if there is a function inside another function, a new scope is nested inside the local scopes. And see here, dear friends, here I just have given you an example of scope and a namespace in the Python. And see here the variable a is in the global namespace, variable b is in the local namespace of outer function, and c is in the nested local namespace of inner function. When we are in inner function, c is local to us, b is non-local, and a is global. We can read as well as assign new values to c, but can only read b and a from inner function. If we try to assign as a value to b, a new variable b is created in the local namespace, which is different than the non-local b. So the same things happen when we assign a value a. However, we declare as a as global all the reference and assignments to the global a. Similarly, if we want to rebind the variable b, it must be declared as non-local. So let me just see with an example for further clarify. See here, dear friends, we are having, that is the definition, outer function, okay, and a is equal to 30, and definition of that inner function where a is equal to 60, and we are just going to have a print a is equal to a. And next comes the inner function. There also we are just making the print of a, and at last a is equal to 90. Outer function, print a. And see here, dear friends, in this program, three different variables a are defined in separate namespace and accessed accordingly. One is outer function, one is inner function, and to that of local function. That is which we just say global. And see, when coming to the inner one, which is the local for that of inner function. And for this inner function, a is equal to 30 would be the global. And final to that of outer function, a is equal to 90 would be executed. And see here, dear friends, let me just see with one more example. And in this, here what we are making is all references and assignments are to the global a due to the use of keyword global. Due to the keyword global. So here just to see everything here it is specified to the first most inner function where a is equal to 60. So it would remain the same in all the functionality, that is all the layers. Dear friends, we are now in second module, data types. In this session, we are just going to discuss about different numbers used in Python, how to convert from one data type to another, that is type conversion, and the mathematical operations supported in Python. Number data type in Python we have already discussed, and we have seen some examples and exercise, but even though here I want to add it with some more information under data type module. So kindly have a note of it, dear friends, that is integers, floating point numbers and complex numbers fall under Python numbers category. They are defined as int, float and complex classes in Python. Integers and floating points are separated by the presence and absence of a decimal point. For instance, 5 is an integer where 5.0 is a floating number. So complex numbers are written in the form x plus yj, where x is the real part and y is the imaginary part. We can actually use the type function to know which class a variable or a value belongs to. Similarly, the isInstance function is used to check if an object belongs to a particular class. Let's look at an example. Dear friends, see here, a is equal to 6, and if we just want to know what is the type of a, actually it is an integer. And if you want to know what is the type of this 5.0, yeah, it is a float. And when you are assigning a variable c and you are declaring a complex number, that is 6 plus 3j, and if you want to make a sum of to that c variable, and see here print c plus 3. Now, what did you want to check? Whether the c is a complex or not with the function isInstant. Okay, so all these functions are all together in a single example. Yeah, A, it is an integer type, and the type 5.0 is a float type. And when an or adding 6 plus 3j with 3, you would just resulted with 9 plus 3j. And at last, whether the C is a complex or not, if you want to check with ease instance, yeah, it is returned with true. And while integer can be of any length, it is only limited by the memory available. The numbers we deal with every day are of the decimal, that is base 10 number system, but computer programs, generally embedded programs, need to work with binary, that is base 2. And we are coming to hexadecimal, it is base 16, and octal, it is base 8 number system. In Python, we can represent these numbers by appropriately placing a prefix before the numbers. See here, dear friends, when we just make use of this prefix, that is for binary 0b or 0b, it is in capital or small letter. And to that, for octal, you can just prefix it with 0o. And when coming for hexadecimal, it is 0x. And let me just see it with an example, dear friends. See here, when we just want to make an output of this one, that is 0b 0001, and what it just be is 1. And to the same, when you just make use of 0 o to that of 12, and see here it is 10, because 12 is octal in 10 in decimal, and I have to use the prefix, that is 0o. And 0x, it is for hexadecimal, and for your surprise 10, it would be, that is a, it would be denoted by 10. Okay, let me just go for the next example, and see here, let me just check with the same pattern, that is 0b, okay, for a binary of 11010111, whereas it just shows as for an example of 107. And when you just want to make this adding hexa number with binary number, okay, hexa number is 0x, and dear friends, this 0xfb, it would be the value of 251, and 0b10, it is the value of 2 in binary. Okay, when you add up of this both hexadecimal hexa number and binary number, it is resulted with 253. And to the same, when coming to this octal of 15, it would be resulted with 13. Okay, next coming to the type conversion, we can convert one type of number into another. This is also known as coercion. So operations like addition, subtraction, and integer to float implicitly, that is automatically, if one of the operand is float. Okay, so let's just see it with some examples, dear friend. See, we can see the example 1 is integer, is coerced into 1.0, that is float, for addition, and the result also a float point number. See here, I just execute here. See, 1 plus 3.0, adding this 1 to a float number, and we are resulted with a float number. And here, when converting the float 6.3 to an integer, the decimal point is truncated. And when coming to the same, when you, even though if it is a negative number, that is minus 2.7, if you are converting it into an integer, so the decimal part is truncated, and it is resulted with minus 2. And the type conversion of 9, it would be resulted with 9.0. And next it comes an example where you want to print a, okay, and see here, dear friends, we can also use built-in functions like int, float, and complex to convert between types explicitly. So that is what we have just done here. But when coming to this float to integer, the numbers get truncated, that is the decimals are removed, that it would be possible. But when coming to a complex number, okay, a complex number, how it works. So before that, let me just see this, the resultant. Okay, see how the a is there. Yeah, it is an integer, so it just shows the integer. And when for the float number, if you want to make it for a decimal thing, only 17 numbers can be displayed. Yeah, we have already seen that. And here displaying the complex number, yeah, it is just showing. And when you want to make a string, that is string 3 plus 6j, to be converted into a complex number, so once after converting, so 3 would be the real part and 6 would be our imaginary part. Next, coming to Python decimal, Python built-in class float performs some calculations that might amaze you. We all know that the sum of 1.1 and 2.2 is 3.3, but Python seems to disagree. How come it is? Kindly just see to this, dear friends. See, if you add 1.1 plus 2.2, and if you are just want to equal to 3.3, here we are just getting false. What is going on? See, actually it turns out that floating point numbers are implemented in computer hardware as binary fraction. As the computer only understands binary 0 and 1, due to this reason, most of the decimal fractions we know cannot be accurately stored in our computer. Let's take an example. We can't represent the fraction 1 by 3 as a decimal number. So this will give us 0.33333, which is infinitely long, and we can only approximate it. It turns out that the decimal fraction 0.1 will result in an infinitely long binary fraction of 0.00011001100 like that. And our computer only stores a finite number of it. So this will only approximate 0.1 but never to equal. Hence, it is the limitation of our computer hardware and not an error in Python. So if in the sense how we can just make use of it. With this, if we check for the resultant of 1.1 plus 2.2, what will be our output? It is 3.30000003. So hence, to overcome this issue, we can use the decimal module that come with Python. While floating point numbers have precision up to 15 decimal point, the decimal module have user settable precision. Let's see the difference here, dear friends. If I just want to, so let I import this decimal, okay, by print 0.1, what would be our output? Yeah, it is just going to print only the 0.1. And when you are just giving this statement, decimal dot decimal of 0.1, just amazing. See here 0.1, how many numbers it is. So this module is used when we want to carry out decimal calculation, as we learned in our previous sessions. So it also preserves a significance. We know 25.50 kg is more accurate than 25.5 kg, as it has two significant decimal places compared to one. So let me just see the same thing with some example. Okay, see here, dear friends. So from decimal, import decimal as D, and I have just given you small calculation, that is 1.1 plus 2.2 and decimal of 1.2 multiple by 2.50. Okay. See here, notice the trailing zero in the above example. We might ask, why not implement decimal every time instead of float? So the main reason is efficiency. Floating point operations are carried out much faster than a decimal operation. Then when to use decimal instead of float? So we generally use a decimal in the three cases. One is when we are making financial application that need exactly decimal representation. Second, when we want to control the level of precisions required. And third, when we want to implement the notation of significant decimal place. Okay, next comes the Python fraction. Python provides operations involving fractional number through its fractions module. A fraction has a numerator and a denominator, both of which are integers. This module has support for rational number arithmetic. We can create fraction objects in various ways. Let's have a look at them. See here, dear friends, we are just going to import fraction, and let me just check three things. One is fraction of 1.5, fraction of 9, and fraction of 1,6. Okay, so this 1.5, how it would be resulted? It is 3 by 2. And when coming to fraction of 9, yeah, it is same as that of. And last one, fraction 1 by 6, that is which is just gives the numerator and denominator. So while creating fraction from float, we might get some unusual results. This is due to the imperfect binary floating point number representation as discussed in the previous session. So fortunately, fractions allows us to instantiate with string as well. So this is the preferred option when using decimal point. And see here, dear friends, let me just see the same thing in an example. So import fraction, okay. If I just want as a float, okay, as a float, and I'm just going to make it as 1.1. See, 1.1 is a number, and what would be my output? Here it is. See here, dear friends, when we just execute this two functionality, see here 1.1 is a number, we are just getting this as a float, and here this 1.1 is a string. Okay, the 1.1 as a string, now it is not a number, and what would be our resultant is 11 by 10. So this data type supports all basic operations, where some of the following examples just shows you. See here, dear friends, the first one, fraction of 1.3 plus fraction of 1.3. Okay, so here my fraction modules, now we are just changing it to f. So wherever if you want to make use of this fraction, you can use just f alone. Okay, and when coming to addition of fraction 1 by 3 and fraction 1 by 3, so this is 1 by 3 plus 1 by 3. So in that sense, mathematically it is asked by the whole, taking an LCM of 3 and 1 plus 1 by 3. So which it results to 2 by 3. Okay. And when coming to this one, print 1 by f of 5 comma 6. F of 5 comma 6 in the sense, yeah, here it just comes 5 by 6. This is 1 by 5 by 6. So this denominator would be converted to a numerator. So the result would be 6 by 5 here. Okay, and next it comes minus 3 comma 10, that is minus 3 by 10, which is greater than 0. No, it is not. And if you want to check with the same thing, minus 3 by 10 is less than 0. Yeah, it is true. So see here, let we execute this and find the answer is discussed. Okay. Next, we just see Python mathematics. See here, dear friends, Python offers modules like max and random to carry out different mathematicals like trigonometry, logarithmic, probability, and statistics, etc. And when on just providing this module, what is the thing is we are just going to use this math library, and once on importing whatever we need, it can be executed as it is. So if you want to go for pi operation, if you want to make use of cos of pi, which is resulted with -1, that is not -1 alone, it is -1.0, because as resulted with an floating point. Okay, and the next comes exponential of 10, and the next comes logarithmic 10 of thousands. Here also it is not only 3, it is 3.0. And when coming to sine of 1 and factorial of 6, factorial of 6 is 1 into 2 into, so in that sense, let me just see the execution. Yeah, see here, whatever we have discussed, it is asked like that, math.py. Yeah, it is giving the result out of a pi value. And when coming to math.py, that is cos of pi, it is -1, but it has resulted with a floating point -1.0. And next comes the exponential of 10, and next comes that 3, not only 3, it is a floating point of 3.0, and so on. And see here, dear friends, the next one comes the random. And here random is in the sense, when we run the program, we get the output function where values may be different due to the random behavior. Random behavior is in the sense, see here, I'm just need to have some 10 of 20, and the next one, x is equal to a b c d e, I have just specified anything that is, it is a list class of variable, and it has a 5 elements. And when making some random choice from this x, it can be of any number or any element from this list. And when making it into a shuffle, yeah, it's this shuffling can be of any order. And printing that shuffle, yeah, once after shuffle we are just going to have the print of it. And last but not least, random. And random dot random function. Okay, let me just execute this and see here, dear friends, when making some 10 till 20, so from 10 to 20 we are just randomly picking one number, and with this list we are just going to pick an element, and shuffling this list, it can be of any order. Now it can be deferred from my output and to your output also, and print this shuffled here, and random of this random element. So here, dear friends, hope this session would be very much informative related to the data types and numbers, and let me just discuss further in my next session. Thank you, dear friends.